folks. So
Okay, I'll stop talking about this stuff now.
And we'll recap all that. So
yeah, okay. Thank you.
If you'll wait just a second here while we're going live, and it's going to be on Grand Strand Astronomers, folks. So,
okay, you're live right now, Ian. It says live in the corner.
We'll recap all that. So
yeah.
Okay, I just had to mute it because I'm, okay, now it's giving, okay. So now we are live on YouTube, everybody. So welcome everyone, for all the folks here in person and anyone that's on the page or watching the recording, to the October meeting of the Grand Strand Astronomers. For those of you that aren't familiar with us, I'll do just a quick little intro. We are an astronomy club in the Grand Strand area, so that's the greater Myrtle Beach area in South Carolina in the United States. We are a new group, so we are an official South Carolina corporation, and we have our nonprofit paperwork pending. We were just talking about that prior to going live. It's in front of the IRS, and I'm sure the IRS is backed up quite a bit, from all the hijinks of 2020. The 2020 has pulled on everybody. So at some point we will get a determination from them that will go back to when we started operations in July. So I don't anticipate a problem with that. I just think it's way behind. John, you can comment if you know anything more about that.
The only thing I know is, according to the IRS website, they are still processing 1023 ECs at August 6th. So anything beyond August 6th has not been assigned to an examiner.
And I understand that. That makes sense because, just of everything that's going on, and they're behind in tax returns as well. So makes good sense. Again, welcome everybody. So this is our regular membership meeting. Of course, because of the current situation and all the COVID-ness out there, we are meeting virtually for the foreseeable future. We encourage everybody to sign up for our Facebook group or ask about the email list on the group's IO site. We also have a membership form for anybody that would like to join. If you join now, you get all of 2021 for all one price. Tonight we're going to have I was working another presentation. Unfortunately, that person he happens to work in the healthcare field and couldn't make the time to do the presentation. He needed a little time off, which you can kind of understand. Given everything that's going on. So I kind of stepped in with an alternative presentation. Next month, we have a very good presentation scheduled on what you need to know about eyepieces from Jim Presley. Jim Presley is a member of the Raleigh Club, and he is an expert on eyepieces. He personally owns probably a couple hundred. And he knows a lot about eyepiece optical design and the advantages, and he's had a lot of experience looking through different eyepieces. And so it's a good opportunity to talk about, what kind of eyepieces are good for your telescope, what you need, and what the various designs are good for. So it'll be a really interesting talk. We're still working on December and later, but I've got several people I'm talking to, trying to get a beginning deep sky observing presentation from one of the folks of the Midlands Club, as well as we've got someone talking who wants to talk about lunar observing, which is a lot of fun, and it's something you can do even from your driveway. So, of course, we were talking earlier before we started the live stream about Mars and the planets that are up. So there's Mars is certainly as bright as it's going to be in like the next 10 years, and so I encourage everybody to look at that. The recent meteor shower this week, of course, was clouded out in this area. And unfortunately, the viewing of Mars and the planets has been kind of a little fishy because the seeing has not been good, and there has been a lot of clouds in this area, at least. Hopefully, wherever you are watching this video, that it's been clear. But if not, try to get out and look at Mars, especially as it gets more overhead, like around midnight. It's amazingly bright, and probably as bright as it's going to be in the next 10 years. I guess before we get started, does anybody have anything they want to say or talk about or discuss? Okay, so I got the deer in the headlights when I threw it open to the group, right? I don't think anyone was expecting to have to talk. Now, great. So I guess we'll go ahead and do my quick presentation here. Again, I do promise it's not always going to be me talking. So it's not. I didn't start this club with Denise and John and Gerald just so I could have a forum to talk. Believe me. So I will. But I was thinking about this. As I was doing some observing this week, and I thought, well, why don't I talk about filters? Because it's something that I kind of took for granted when I first started. I actually thought about it, and then I took it for granted, like most people do. So we'll kind of talk a little bit about it. Let me share my screen here. And if anybody has any questions, I encourage you to ask them. Okay, so hopefully you are able to see my screen.
Yeah.
Okay. Sorry, I was just making sure that came through on YouTube. Since there's a little bit of a delay, let me bring up the chat box so I can see what's going on. All right, so, okay, it's not in presentation mode. Now it's in presentation mode. Okay, so the way I entitled it, you can tell I'm getting kind of punchy because I'm also naming all my assignments for my students with bad puns now instead of just, very formal kind of names. So you can tell that, like the 7 days a week are getting to me. So I call this presentation, I Can See Clearly Now, sort of. And it's all about filters in astronomy. You could actually do several long talks about filters. There's a whole bunch of considerations especially for astrophotographers. We're not going to talk about that tonight. Although if people are interested, I can talk to a couple members of the club and a couple other people I know to talk about the use of filters in imaging or astrophotography. They are very useful there. There's some different filters you use and different ways you use them. But I'm going to talk about the ones you use for visual observing. A lot of people don't think much about using them for visual observing. Ironically, a lot of people do have some filters and they rarely ever use them. It's just not something you think of, but actually they can be really useful for visual observing, but kind of in a little different ways than most people think. It took me a while to sort of understand that, because I kind of, when I first jumped in and bought a bunch of stuff and then, got disillusioned, right? And so, well, I kind of put it in my bag of tricks, right? And didn't pull it out for a long time. But now I even use them when I do public observing. So it turns out it's really pretty handy. So, let's, if this were a traditional filter presentation, and believe me, it's not. So, I would start out by giving the standard lecture, right? That there's like really 3 kinds of filters, right? There's like broadband LPR filters. They let a lot of light through and they just sort of notch out some things. Basically just knock out the transmission in certain wavelengths. There's narrowband filters that only let through a few things. And there are specialized nebula filters that only let through very, very narrow pieces. And, that's a good way to talk about it, or to understand sort of the general descriptions, but I don't really think it's, I kind of aim this a little more practical advice, right? If you're interested in what notches or what the transmission curves are for any of the filters, now with the internet, any manufacturer, you can go and you look up what their the band pass is, or what their what they notch out, or what their transmission is. And there's also a lot of sites that will compare different filters, right? That's one of the beauties of the internet, and astronomers love to post stuff about equipment. You can go on cloudy nights and get a lot of good opinions too. So I'm not really going to talk too much about that. I'm kind of going to talk a little more general, right? So most people have some filters, like you may notice the little colored filters. It's amazing how many people, I'm sorry, was that actually a question? Sometimes when I get going, I don't pause. So I just, sorry. So most people do have filters, right? Like these colored filters, they come with a lot of packages, right? Like if you got one of those eyepiece packages, like Celestron sells them, Mead sells them, they sell you a nice little case and they sell you a selection of eyepieces. And, a lot of times they throw in a few color filters, or you can get them from somewhere like Orion or somebody, and they're cheap, right? Like they're $39 or $29 or $19 for a basic set of the filters, right? So maybe I can't spell maybe, but maybe purchase one or two of them yourself, right? Here's a couple of examples of CLS and UHC from Astronomic. I kind of like Astronomic. They're one of the higher end filter companies. And maybe you have a couple of those, right? A lot of people end up buying a couple of filters here and there. This is, if anybody is familiar with the hype curve, I got this from Gartner, but this is the hype curve for any product or technology or anything, right? So there's something that triggers it. So basically, in this case, probably you deciding to do astronomy. And then you get a telescope and you like it, and you're like, I want to make things a little bit better. And so a lot of people tend to buy filters. And there's the peak of inflated expectations. Basically like when a new technology comes out and everybody thinks it's going to be awesome. Same thing, you buy filters, it's going to be awesome. And then there's what they call the trough of disillusionment. And that's when it probably doesn't work as well as you might have suspected. And maybe you just kind of put them away in your kit and not use them. But then you get to this point of what they call the slope of enlightenment, which is, well, maybe it is useful depending on how you use it. And there's like this slow curve up. And then there's the plateau of productivity. And that's the technology hype cycle. But I think it also applies really well to filters, right? Because I think people get the filters and they expect them to be miracle workers, and they're not. And they sort of get disillusioned. And that's where a lot of people stay. Then you sort of, for some people, you get to the point where you start using these filters. And if you use them in a productive way, not expecting miracles, it turns out they're very handy, right? And they're very useful and they're nice to have. And then you sort of get to that plateau where you kind of use them in the right circumstances and for the right kind of things. So, okay. So the filtered reality. Don't expect miracles out of any of these filters, right? There's no magic solutions. You can't be in downtown Myrtle Beach and buy any filter whatsoever that realistically for visual observing is going to make it like you're somewhere at a dark sky site. So like Hampton Plantation or someplace like that, there's no there's no filter that's going to do that. But again, don't just stick them in a drawer or stick them in your plastic bin. Like I got all these plastic bins with all my excess observing pieces that I've gathered over the years, pieces and connectors and cables. Don't just stick them in a drawer. I would definitely carry them out because they can really be useful, right? If you use them correctly, they can be really handy and great to have. So let's kind of talk about that. First, I'm sorry, was that a question? Okay, so the first one is older light pollution filters. And I say older, and when I say that, that's really means anything that's not developed just in the last couple of years. So there's a kind of a newer generation of light filters out that we'll talk about in a minute, but most of the older light pollution filters, and that's what I've got because I've been doing this a long time. So they are designed, the theory is they're designed to block out wavelength of light pollution. And I would say it's okay at best, depending on your local circumstances, but that's okay at best. And sometimes they're not that okay at all. Again, you can't expect miracles for these. The goal, of course, is to block out a lot of the street lights, the light from street lights, and also oxygen lines from air glow. And I'm not sure if anybody's familiar with air glow. Here's kind of a little bit of an exaggerated picture from the ESO over the VLT. And you can kind of see some air glow. If you've ever been anywhere under a really dark sky, like the kind of dark sky where, like, if you look when I used to observe at some really dark sites and I had a station wagon, I'd look at the back window and you could see all the stars brightly reflected in the back window. That's how dark it was, right? When you look at the sky in a dark sky site, it's not black. A lot of times in these light polluted skies, it's black. It looks black. But when you actually look at it at a really dark sky site, it's not black. It's sort of this bluish color, right? So what you're actually seeing is, if you're lucky enough to be a really dark site, you're seeing air glow, and these are oxygen lines from air glow. So that's just something that happens. But it's to see it visually without just from the naked eye, you really got to be at a dark sky site, but it's there. So that's one of the things the older light pollution filters try to block out, right? Fortunately, those are very narrow lines, so you can block those out. You see these marketed as LPR, light pollution reduction filters. That's a great marketing term. And CLS, I guess, which is something light suppression. They tend to really push that, like, oh, cut down if you've got light polluted skies, cut down light polluted skies. And it's a case of where a long time ago it worked to more effectively than it did now. And let's talk about why. Let's talk about a little bit of streetlight history. Okay, say like in the late 1940s, early 1950s. At least this is a very U.S. centric. It might be different in other countries. There were the streetlights that were going in were the low pressure mercury vapor lights. And many of you may have seen these because they're still around in places. The thing is, if you look at the spectral signature of those, it's got a couple of bright lines, and that's it. And with the light, those first generation light pollution filters, the ones that came out even like 20 years ago, if you had mercury vapor lights in your neighborhood, you could literally take one of those filters up and hold it up looking at the street light and not be able to see the street light. It would just completely block it out. There's one area, the city I used to live in, that had those lights, and you could do that. Unfortunately, the bad news is that those are still around in some places, but not a lot of places. They got replaced with high pressure sodium and sometimes low pressure sodium, but mostly high pressure sodium, starting in the 1970s. That made it a lot more difficult because you can see the spectral signature for the sodium. I guess one of the theories is a little more natural light, but it has a lot more lines and puts out a lot more light. So it gets a lot harder to filter that out, because you're filtering out so much light that if you filtered that all out, you would filter out a lot of the useful light from the objects, right? So a little more recent history. So the sodium lights got replaced in some areas by metal halides. And they have like a constant level of light with some really significant peaks. And they're not as widely deployed as some of the other things. However, the current problem with light pollution filters in general is LED lights. These are going in a lot of places because they're very efficient. And you can see some of the different colors, and you can see the spectral signatures for that. And the problem is they're pretty much broadband, especially if you look at the daylight ones. And I noticed they've installed some daylight colored ones in my neighborhood now. So basically, they're blasting out across the entire spectrum. So you can't really filter them out. So it's just something you got to realize if you go to use the light pollution filters, is depending on what you have in your area, they're going to be maybe be very effective or not so effective at all. How to tell? Well, it's really hard to tell what's in your local area. You can try Googling, because a lot of times that information is out there. You can also check your streetlights. If you look at your streetlights, if it has a NEMA, that's the National Electric Code, one of the National Electric Code organizations, wattage label on there. If it has one of those labels, and not all of them do, I know they don't in my neighborhood, but they've been in other neighborhoods I've been in, that NEMA will have that label, which indicates the wattage of the light, will have a color. And that color will tell you what type of lamp it is. So that's required if it's actually a NEMA wattage label. So you can also check that. But I mean, realistically, you kind of gotta just, temper your expectations with these light pollution filters. If you're taking images, again, you just want to take shorter exposures. If you're doing visual work, you're only going to be so good, even with light pollution filter. Now, there are some newer ones that have come out in the last year or so, or 2 years, I guess. I call these next gen light pollution filters, but that's not, oh, sorry, hit my keyboard there. But it's not a commonly accepted term. You know, there's still a compromise. One of the ones that's getting a lot of press, at least recently, is called the Optolong L Enhance. And it's getting pretty good reviews. And what it does is it tries to notch out some key lines to try to preserve like star colors and preserve some of the key elements of the things you're looking at. It's not going to be perfect, but it's getting pretty good reviews at helping some. But again, you kind of got to temper your expectations, but it's only going to help so much. So, I mean, basically, one of the questions I guess you could talk about is what would be the first filter I would buy and what would be the last filter I would buy, which I cover in this presentation. This would light pollution filter would not be the first filter I would buy. Again, depending on if you are doing primarily astrophotography, we could talk about that another time. There's some filter choices, light pollution filter choices that may make sense. But again, for visual observing, I'm not sure this would be the first thing I would buy or even the second filter I would buy. Now, we talk about nebula filters. The good thing about nebula is that they emit primarily in a much smaller set of wavelengths. And the good news is you can get filters that focus on these certain lines that are strong in nebulae, right? This is a little bit different. These actually really do work. Again, you're not worried about some of the broadband lights, like the daylights, like the ones that are the wavelengths that are predominant in stars. You're not worried about that at all. So basically, you can get rid of that. So these are actually really handy, and they really do work well. They allow you to they really bring out things, especially planetary nebula. Now, the one thing to realize, and when you're looking for them, is that some have a strong color cast. Especially even some of the good ones do. Like I have Astronomic, which is one of the better rated UHC filters. That's ultra high contrast, which is how they market some of these filters. And mine has a greenish cast to it. And if you can get over that, then it actually works very, very well. So these filters do work. And actually, the one thing about these is, unlike the colored filters, quality matters here. There are some cheap ones that are okay, but if you're going to invest in this, and I would actually recommend, if you don't have any filters and you decide you're going to buy one, the UHC would be the first thing I would get. Probably the first one I would buy, and it probably was the first one I bought. But quality matters here. Lumicon makes, I'm sorry, was that someone signaling for a question? Sorry, okay. Sorry, I have a window on my screen of video of everybody. So Lumicon makes a good one. Some very good ones are Astronomic out of Germany, Optolong, and Botter out of Germany. So they make very, very highly respected filters. They cost a little bit more, but they are worth it. Again, you want to probably, if you want to buy one, you probably want to look at the various reviews and the comparisons between that filter that you're looking at and some of the other ones like the Botter and the Astronomic. But when you get a good one, they are really very useful to looking at nebula, like whether you're looking at the Orion Nebula, or the Ring Nebula, or anything, it really does pop out. And there are some very faint nebula that really, really benefit from having these UHC filters. And I'm talking about visual here, not just astrophotography. So a lot of people actually get some people even get the filter slides to where they can sort of blink the filter in to find things. So they put the UHC in, then they look at it without. And a lot of times you can visually see just the really faint nebula will just sort of pop right out. So I definitely recommend the UHC filters. I think it's something you'll definitely use quite a bit of when you're out doing observing. So, okay, hey, if the nebula filters and the narrow band filters are great, what about the line filters like the O3 or the hydrogen beta filters? These are even more narrow band. They only let through just a few lines, right? They actually do an excellent job for what they're designed to do. I mean, they really do an excellent job. Unfortunately, they're only designed for a handful of objects. I think like the Horsehead Nebula is one, and there's a couple others that you use the O3 and the hydrogen beta for. Because of that, it's probably the last filter you want to acquire. They're not to get a decent one is not cheap. And again, they're used for just a handful of objects. So again, unless you just want to have a complete set and money is no object, then it's probably the last one you want to acquire. Because if you get a UHC filter, the narrowband, it will work for a wide variety of objects out there. Enough that it's definitely worth doing it. But again, these line filters, you'll be happier with the UHC than you will the line filter, unless you happen to be just like someone that wants to go out and look at the Horsehead all the time. So let's talk a little bit about these color filters, right? So now we talked about some of those high-end filters, the UHC, and we talked about the light pollution filters, the CLS filters. What about the color ones? Well, they can be had cheap. Where some of the UHCs can be 100, 200 or more. You can get a pack of color filters for $20, $30. You can get them from Orion, you can get them from Celestron, Meade. Again, that's probably why a lot of people throw them in to like the eyepiece kits, because it's sort of adding content and value without adding a lot of cost, right? A lot of people get them and just never use them, right? And it's interesting because they're actually surprisingly useful for visual astronomy. I think you might be surprised when you start using them just how useful they really are. Again, for the right situations. You don't want to use them all the time. And the bottom line is they're a great bargain for the cost. I mean, they're cheap. And you can actually get a lot of use out of them. I use mine quite a bit. Again, you kind of have to get in the mode where you think about using them, right? And why you would want to use them, right? And then once you kind of get used to that and kind of carry them with you, you'll find that you do use them. So let's talk about that. So what do I mean by all that, right? Well, the way they're identified is something called a Ratten number. And this is out of the photography days. So you can Google this if you want to know all the history. And it looks like there's a lot of Ratten numbers here. But there actually aren't very many. There's actually a huge list, even just on Wikipedia, of Ratten numbers. There's a tremendous number of different kinds of filters. There's kind of a subset that are used in astronomy. But if you have something that's close, like you say, if you have photography, if you've done a lot of terrestrial photography, you may have some Ratten filters that are close, and you can probably use those too. But the Ratten number is a way to ID both the color and the light transmission. When I say light transmission, that's the percentage, how dark the filter is, how much light comes through, right? Again, there's a lot more numbers. Here's a list of some common ones. And then here's like a color wheel of the various colors and some of the numbers. Again, you can look up online, and there's various, there's a whole huge number of Ratten filters. And usually anytime you buy an astronomy filter, they will have Ratten numbers associated with them, right? So you can kind of tell what's what. So let's look at one type. It's Ratten number 96. This wasn't on that filter wheel, but they are gray filters. So you also see this as called neutral density, or ND filters. You see that a lot. The reason you want to use these, especially if you've got a telescope of any size, is when you look at the moon. Try looking at the moon, especially when it's in one of the brighter phases, and with a fairly large telescope, like an 8 or 11 inch telescope, and you'll see your retinas like tuna steaks. I mean, it's bright. And it makes it hard to see some of the detail. I mean, it really is bright. So these moon filters are really handy for if you like to look at the moon, you can get them. They're not expensive. And they'll help you preserve your night vision some when you look at the moon, right? It's actually a lot easier to see detail than it is just using it with the super bright, unfiltered view, right? I mean, the moon is just so bright for a telescope. You really need to use these filters. So again, you'll see them as Ratten 96, but most of the time you see neutral density, or they'll be called moon filters. Like I think Orion calls theirs a moon filter. But most of these have a transmission of about 13%, which is close to an optical depth of 0.9, which is another way of kind of expressing transmission. But something close to 13% is fine. It doesn't have to be exactly 13%, but you get the idea. Is excluding pretty much 90% of the light at that point, right? And that's perfectly fine for a moon filter because again, the moon is so bright. I definitely find these are handy to use, and I've got a really simple one that I use. Again, the good thing about only having a transmission of 13% is that it's really not a case of where you have tremendous optical quality that can be produced very inexpensively. So a lot of the moon filters are cheap. So, but I definitely recommend them if you like to look at the moon. So definitely do that. Another alternative for looking at the moon are polarizing filters. And these are still mostly used for lunar viewing, but you can also use it for other really bright objects if you want. Again, both of these have the advantage of they don't change the color. The reason they call them neutral is they don't change the color of the object. So there's no color cast whatsoever. It just darkens everything. No color cast whatsoever. Same thing with polarizing. So the way it works is you can see it's in two pieces. This is the Orion one. It's in two pieces. And you can see, and then what you basically do is you kind of rotate the two pieces and it adjusts the transmission for anywhere from 1 to 40%. So basically it will cut down the amount of light you want to cut down. So you cut down more or less. I don't have a polarizing filter. If you have one, it's great. If you want one, it's great. I find I get along just fine with the 13% of neutral density filter. I don't think I need that flexibility. But again, if you have one, you certainly can go ahead and use it. It's great to have a little more flexibility. And again, it kind of keeps the natural color of things, so it's pretty convenient. So again, I would definitely recommend getting that, especially if you do outreach events and you're looking at the moon. But let's talk about some of the colors. Probably the most popular ones are the blues. And again, it's popular, but a lot of people, again, don't think about using them, right? It keeps a reasonable, it turns out the blue is kind of funky in that it keeps a reasonable color balance. I mean, it's obviously going to do a blue cast, but for some reason, I don't know why this is, it doesn't seem like the blue cast is as obvious, or it doesn't bother you as much as some of the other color filters that will put a significant cast of, say, like yellow or orange or something. For some reason, the blue tends to just be less obtrusive. I don't know why that is. That's strictly anecdotal, but other people have noticed that as well. So it's one of the most popular. I mean, there's the light blue is 82A and the blue is 80. One thing that this also works very well on the moon. So if you don't have a neutral density filter, you can try doing a blue filter. And you might be surprised that it actually brings out details on the moon, right? Actually helps you see more details on the moon. And that's actually really interesting. On Mars, it actually helps you see clouds and the ice caps, and it can really bring those into focus. A lot of people don't think about using these color filters when looking at planets, but planets are bright, so there's a lot of light. And when you use them, when you use these color filters on planets, it really brings out some of the details on the planets, amazingly so. Again, so much so that I use some of these color filters when I do public observing, especially if there's a lot of people, say maybe there's 3 or 4 telescopes all pointed at Saturn, and then I'll put in a color filter to bring out a feature of Saturn, and a lot of people will comment that they can see the difference, right? So again, clouds and ice caps on Mars. It's actually very excellent for seeing the red spot. If you ever try to look for the red spot on Jupiter, it's not always that easy to see. Again, if you use blue filter, it is a lot easier to see, as well as festoons, all the little mini storms in between the bands, right? And Saturn, it's a good way to bring out the bands on Saturn. I mean, a lot of people, when they look at Saturn through unfiltered scope, Saturn itself just looks like a sphere without much color variation on it. Actually, it does have bands like Jupiter. And with the right kind of filter, you can actually see them. They sort of really pop out at you. So again, blue and light blue are really good for that. The main difference between light blue and blue is that light blue passes a lot more light through. So the brighter the object, you can probably go the deeper the blue, right? So like the moon, you can go blue. And when Jupiter's very bright, you can go blue. For Saturn, you may want to think about light blue, and maybe Mars, depending how far it is away, maybe light blue.
Question.
Yes.
I tried looking at Venus one time, and it's too is very, very bright. So what filter do you recommend for that one?
Yeah, there's a couple of them that you can use for Venus to see the upper clouds. We'll go talk about that in just a minute. I didn't put a lot of Venus stuff in here, but there are some colored filters that really, again, Venus is so bright, you can use some of these deep colored filters and you can actually bring out some of the details in the clouds. Yellow. Yellow is another good one. Again, 8 being light yellow and 12 being yellow. It's surprisingly effective. I read some stuff about saying it's pretty good. I think it's surprisingly effective. For me, yellow is, I use it a lot. I prefer the light, but it's definitely useful. What I have read is it can be useful on Uranus and Neptune to actually bring out just a little hint of detail on that. Now, that's not something I personally tried. I actually saw it when I was doing some double checking for this presentation. I am going to try it though. Never thought about using it on Uranus and Neptune, but I have used it on Jupiter. And Jupiter is really excellent for bringing out the bands and the belts. Mars for the dust, Maria, and clouds, and the moon. It's actually really good if you've got a small scope and you use the light yellow filter. Surprisingly good. Orange. Orange is a really interesting filter because it's got a lot less transmission. And it definitely has a strong color cast of orange. But the neat thing about it is that it's amazingly good for daytime viewing to cancel out the blue sky. Now, daytime viewing is the thing most people don't try to do. Certainly, you can see Venus in the daytime. That's pretty, you can see it with the naked eye. But you can actually look at it through an orange filter, and it looks even better. A lot of people look for Mars and planets during the day, too. With computerized scopes, it makes it a lot easier. And you'd be surprised if you use an orange filter, those targets will jump out and you can actually observe them during the day. A lot of people like it orange for the moon the best, again, because the moon's so bright. They think it brings out the details the best. I've heard that. I haven't really tried it on the moon. After I read it for this presentation, I'm going to go ahead and try it. Certainly Jupiter, to see, you can see some of the belts and the interactions. And Saturn, it's okay for the bands, but again, orange is a pretty heavy filter with low transmission. So you don't really use it for Mars and maybe not much for Saturn. But again, for daytime viewing, it's fantastic. I was surprised the first time when I first read that, and the first time I ever went to use it to view some planets in the daytime, I was surprised at how well the orange filter really works and how much it really brings out the details. And then there's red, light red and red. Again, the red has a very much a deep, so low transmission. It's actually really good for viewing Mercury. When you're viewing Mercury, again, usually it's sunrise or dusk or in the morning right before sunrise, because it never gets far from the sun, of course. So red is actually really good for that. It's also good for the upper clouds on Venus. Again, especially the number 25, the red, because Venus is so bright and it cuts back on the light. But a lot of people say it's really good for the upper clouds on Venus. So if you get up early in the morning, you can look at that. It turns out it's also really good for like the polar caps on Mars. They can really jump out at you. Jupiter, again, general contrast improvement. I haven't used a lot of red on Jupiter, but a lot of people say it is. So again, red usually comes with every set, so it's worthwhile trying it out, especially if you're looking at Venus. Green, light green, also is supposed to work very well, especially green on Venus. But again, same thing with the moon, brings out some details. The interesting thing about green is it's actually excellent for dust storms on Mars. A lot of people say when they get those dust storms, you can actually pick them out really easily with a green filter. I personally haven't tried that on the last big dust storm, but I've heard it from enough places that I believe it. Also very good for seeing the red spot when you use the light green. Kind of really increases the contrast on that, as well as the belts and some of the features. Jupiter's got a lot of interesting features, which is why so many of the different filters work well for seeing some of the details, right? It's got, not only does it have the various belts, but there's interactions between the belts in the different zones. And there's a lot of really neat, if you've got a larger telescope, there's a lot of really neat details you can see on Jupiter. And of course, Saturn also brings out the bands, right? So I personally still prefer yellow, frankly. That's the first one I go to when I'm like looking at Saturn or Jupiter for the bands, but these other ones work as well. Of course, then there's violet, 47A. This is a really dark one, but it comes in a lot of the sets. It's got like 3% transmission, right? So it's like really not much light gets transmitted from this thing. But it's one thing that it's supposed to be good for is for cloud details on Venus. So it's another one to try on Venus. Again, I haven't personally tried that. I haven't used a lot of filters on Venus. If I can get up early here in the next couple of weeks, I might try because Venus is up in the morning and see what I can find. But definitely apply some of these filters when you're looking at Venus. The other one that you might want to consider is called a minus violet or a fringe killer. These are really good if you have an achromat refractor. So if you have a refractor, and if you've got a really expensive apochromatic refractor that you pay a fortune for, you don't need them. But a lot of the achromats now that turn in good images, but are more inexpensive, have a little bit of chromatic aberration. They kind of have that. If you look at something bright, like a bright star, you kind of see that purple fringe around it, right? And that's it's called fringing or halos, but really it's the chromatic aberration. It doesn't mean you've got a cheap scope. It's just the achromats are only so good at focusing all the colors in one spot, especially if you've got short focal length. They're only so good. If you want a perfect scope, you get one of the Apos, but of course you definitely pay for the privilege. But the neat thing about it is there are minus violet filters that really make a big difference. Here's one of them. Here's the star Sirius. I know probably most of you don't speak German, but basically without the filter and with the Bader fringe killer, filter, which they make one they call the fringe killer. And it shows you how much it really kind of reduces the haloing for even a relatively inexpensive refractor. You can see it's 150 millimeters, so a 6-inch refractor at f5. It's a pretty short focal length, so the fringing is pretty bad. Personally, if this is an issue for you and you want to get a fringe killer, the best is called the Bader semi-apo filter. It's a little more expensive. I've got one that I use in my achromats, and it's fantastic. Anytime I've gone around star parties with people that have big refractors or refractors of any size, and I say, hey, try this filter out, and I try it. I've had people try to buy it from me that's right then and there. So it actually works very, very well. Now it darkens the image a little bit, but it really does eliminate the color fringing. So it'll make your achromat perform like a much more expensive telescope. So definitely something to consider. I definitely think it's worth the money. So that's the long and the short of filters for visual observing. Again, I want to encourage everybody to give it a try because I didn't for a long time. I had them in my kit for a long time and just never thought about bringing them out. And I can't remember what brought it out the first time. I think maybe I was doing one of the AL observing clubs or something, and somebody recommended using one of the filters. And I started kind of using them periodically and realizing that they actually do really work very well for certain situations, right? There are times you just want to go and do deep sky, and that's fine. And, that's really not other than when you might want to use a UHC filter. But if I'm like at a star party doing deep sky, I may have my UHC filter out depending on what I'm looking at, but I may not even use it. But a lot of times, especially when I'm doing stuff in my driveway or doing public observing, I'll definitely crack out the filters. Because you can actually really get some really good results or some really interesting results. A lot of people don't think about looking for details on the planets. They look at them and they say, okay, that looks nice, but you'd be surprised the number of details you can actually tease out on a decent night. So, okay, so that's the long and the short of it, or probably more long. So does anybody have any questions, comments, rebuttals?
So the only filter that came with my scope is the moon filter. And I haven't tried it yet, but after tonight's message, I think I'll give it a shot. Now, would that work on other planets as well?
You know, maybe if Jupiter seems real bright, yeah. But primarily the moon filter is good for the moon. But again, once you try it, I think you'll be really happy with it.
Yeah.
It's one thing that a lot of people do get. You know, a lot of people get it and they never think about to use it. It's really easy to put it in a drawer somewhere.
It's still in the box.
Yeah, that's very common. It took, again, same for me. I didn't use it initially for a long time either. I'm not sure what got me to use it the first time, but then I was like, hey, wow, this really does work, right? Because the moon's just so bright. I mean, if you have, like, say, a 60 millimeter scope, you know, you may not have as much problems with the bright moon. But if you've got an 8 or 12-inch scope and you put that sucker on the moon, I mean, you know, it's like, you know, hold your hand in front of the eyepiece sometime and just look at the, without a filter, and just look at how much light is focused on your hand, right? It's incredibly bright.
Ivan.
Yes, Ronnie, do you have a question?
Yeah, I got a comment or a question too. Is there any way that you could print these out and send me a copy of it? What you just showed us on all the filters? I tried
Yeah,
to write them down, but
I can
I'm
send you.
struggling.
I can send you a PDF.
All right, thank you.
Let me take a note. I have to write things down or I don't remember them. Eventually, we'll post these on our website. We're still working on our website, so.
Yeah, I have one of the Celestron kits, so I've got all the filters in my kit, and you know, I use them. I use them a lot. I really like the blue on Jupiter and the green, the moon filter, of course. So I always keep it right out there. So when I'm looking at something, I can always grab a filter and screw it in.
That's great. In fact, I kind of recommend that, especially if you're set up in your driveway, you know, and you may have some light pollution. Most of us do, right? Unless you live, you know, way out.
Yeah.
And you may be looking at just a handful of things, like maybe just out there looking at the planets. So like say, hey, I'm just going to try some various filters. And it actually turns into a really nice night, you know, looking to see the effects.
Yeah,
Again,
now
it's just, when I first got those colored filters, I can't remember how I even got the first set, you know, it came in something or whatever. And again, I left it in the little plastic thing and it was just stuck somewhere. And I eventually, for some reason, got it out and started realizing that it was actually useful, right?
Yeah. Right now I've only got one 2-inch eyepiece, so, and it's a 36 millimeter. So I'm looking at nebula and big stuff, and I'm trying to decide which like a UHC filter I might add to my bag of tricks.
So I bought a 2-inch UHC because in my diagonal, you can actually screw the filter in the diagonal. Which means that that way it screws in my, I've got a TeleView diagonal, but there are other diagonals that are also threaded.
Right.
And I screw a 2-inch filter in. I bought the 2-inch one, so I could screw that into that. And then no matter what, whether I'm using a 2-inch or a 1 1/4-inch eyepiece in that 2-inch diagonal, I don't have to move it back and forth. I can just attach it right to the diagonal. So.
Yeah, I think last time I was out, I actually screwed it into the Barlow, and that way I could swap eyepieces out. But you're still at higher magnification, so.
I probably should have talked about that, but yeah, that is handy. So if you get the 2-inch, if you get a 2-inch filter, if you're going to use it, if you want to swap eyepieces, you can do that, and just if it screws into your diagonal. So.
Yeah. Yeah, I don't have a diagonal. I'm running a 12-inch Dobson, so.
Well, okay, yeah. So if you're running a DOP, you might not have a diagonal, so
Right.
maybe you just want to get 2-inch, you know, filter. So most definitely. So.
Well, it's a good presentation. I got a lot out of it.
Well, I hope it gets everybody to think about using the filters a little bit, right?
No problem.
Does anybody have anything else they want to talk about, or any questions, or about things coming up, or observing things coming up, or interesting astronomy things, or? No? Well, okay, so what I'm going to do is I want to thank everybody that's watched the live stream. The people that are here alive on the Zoom, we can stay and talk a little bit, but I'm going to go ahead and close out the live stream. And thank everybody that's watching either live or recorded. Let me try to do that right now. All right, well, it looks like it's